This free response question particularly deals working with two-dimensional arrays. This 2D array contains doubles. We see that by looking at the SkyView class here, the data type for this field or instance variable view holds doubles. Now again, I'm assuming you've read the question, you have a general understanding as to what is being asked of you. The tricky part for this question is that we're going to need to traverse through this 2D array in a unique fashion. We'll go left to right, then right to left, then left to right, then right to left. And so the challenging part is well, how do we translate that to some Java code to alternate directions? So we'll look at that in just a second. But let's ensure that we understand what the constructor in part A is asking of us. We'll need to create or instantiate the two-dimensional array that is our field named view. So it's been declared. We'll need to instantiate it using the new keyword in our constructor. And we're going to need to fill all of these elements from the scanned array, that one-dimensional array, and place them into our 2D array. So you should kind of be thinking, well, I need to keep track of the index for my two-dimensional array, so I'll need a row and a column index. And you're going to need an index to keep track of where you are in the one-dimensional array of all of these scanned values. All right, so let's get to writing our solution. Again, you'll notice the parameters passed for this constructor is a number of rows and number of columns here. So the very first thing we'll need to do is the 2D array view has been declared in the SkyView class as a field, but we'll need to instantiate. So to do that, we'll call on the new keyword. And this is a two-dimensional array where the size of this 2D array is given by num rows and num columns. Okay, so now we have instantiated view 2D array. And like I said, we'll need to keep track of the scanned array index, meaning where are we in the one-dimensional array of all of this data here. So we'll need to keep track, are we at index 0, index 1, index 2, index 3. So we're going to need to make a separate variable for that. So I will set that as scanned index, so that way it reminds us that that is the index for the scanned array, which is separate from the row and column index of our 2D array. So we'll start that at 0. Now let's just start by writing our for loops to traverse through the 2D array if we were to simply go in row major order, which is if we were to consider going all of row 1 left to right, all of row 2 left to right, all of row 3 left to right, and all of row 4 left to right. You've seen that before. We'll use R for the row index, such that R is less than view.length. Remember, when you call the dot length of a two-dimensional array, that returns the number of arrays inside your two-dimensional array. A 2D array is just an array of arrays. And we'll go up by 1 every time. And if this was just a regular two-dimensional array where we were traversing in row major order, this would now read C equals 0, such that C is less than view of 0. That'll give us the first array in our view 2D array, and C will go up by 1. Okay. And then what would we do? We would assign view of RC is equal to, well, we want to take the first element from our scanned one-dimensional array and place that at 0, 0. So that is assigned the value of scanned, name of the array, of scanned index. And then scanned index should go up by 1. But this is not how this question is asking us to handle this data. Instead, we have to alternate directions. So we need to think about this here for a second. So at row 0, we go left to right. At row 1, we go right to left. at row 2, row index 2, we go left to right, and at row 3, we go right to left. So the direction that we're traversing through the 2D array, if it's an even numbered row index, we'll go left to right, and if it is an odd numbered row index, we'll go right to left. So this loop here, this is what tells us whether we're going left to right. Right, this is the column index. Column index starts at 0, then we'll go to 1, then we'll go to 2, etc., etc. This should happen if the row index is even. So if it is divisible by 2, divided by 2, and there's no remainder, then we should do this. Okay. But if it's not an even row, then we're going to need to go in the opposite direction. So we'll need to start at the end. So think about what is the last index of a row. The length of this row is 3. The last index is 2. So we'd say C is equal to view of 0, that's the row, dot length, minus 1. We'll keep doing that as long as C is greater than or equal to 0, and the column index should come down by 1. Now, this is just going to make the column index start at the far right and work its way to the left. Everything here is the exact same. Nothing changes. We're still assigning a value from the scanned array into our two-dimensional array, and then we up the scanned index by 1. And that's it for part A. Again, the most challenging part of this problem was certainly figuring out how to determine whether you should move from left to right or right to left. Okay, next we'll look at part B, which is computing the average. Now this is a pretty standard two-dimensional array algorithm, and it's hopefully one that you're familiar with. When we look at part B, we are given a starting row index, which in this example would be 1, an ending row index, so that's 2. So we have a lower bound and upper bound for the rows that we're given, as well as a start column and end column index. So you should be thinking this is just like traversing through any 2D array. We'll use nested for loops. We know how to compute an average by adding up a total, and we'll return the sum of that total divided by the number of elements we have. The only thing that changes is the starting and ending case. So we'll need to keep track of some kind of total. Again, when you're returning an average, you'll need to make sure that at least your dividend or your divisor is a double, so that way we don't get an integer division error, especially since our method header says we need to return a double. Additionally, I think the easiest way here to keep track of the number of elements you have is to just keep a counter. You could certainly do an end row minus start row plus 1 and all that jazz, but I like to just keep a counter. Keep that simple. Okay. So again, to traverse through this two-dimensional array, we'll need to use a nested for loop where this time we're starting at the start row index. We'll go as long as r is less than or equal to end row. And if you look at the free response here, you might be asking, well, is end row a valid index, or do we need to go r is less than end row? And when you read the precondition, you're guaranteed that end call and end row are appropriate values. They will always be less than the length of that array. Now we'll get the columns. Start column, So C is less than or equal to n column and C++. Okay, so we have this running total, so sum is equal to sum, the old sum, plus view of RC. You could certainly use sum plus equals as well. And then I'll add up my counter for how many elements we have added so far. Once we're done with all of that, we simply need to return the sum divided by the number of elements that we've added up. Again, to avoid integer division, we need to make sure that either sum is a double or n is a double. N is an integer because it's how many elements we have in our collection, but sum here is a double, so we are guaranteed to get a double back. And that is part B.